Hello everyone, welcome back to the new session. So in the last session we have discussed about track bar, like how we can create a track bar and how we can find the particular positions of any track bar, right? So in this sessions we are going to learn about the image smoothing, or we can say image blurring, right? So the name justifies everything. Image blurring means like, or smoothing means whenever you want to like highlight some unnecessary informations about the images, or let's suppose if you want to reduce the noise from your images, then in that case we can use image smoothing or image blurring, right? So that we can we can focus on a particular sorry, we can focus on a particular object, right? So basically, let's understand about the definitions. Image blurring refers to making the image less clear. You already know, like when you blur any images, right? So it will become less visible or less clear, right, or distinct. So basically, this helps with the this is done with the help of low pass filters, right? Because you know noise is the high pass okay, noise has high pass frequency, okay, or you can say high pass intensity. So how we can reduce the high pass intensity? So we need to apply the low pass filter, so it will only allow the low pass intensity to pass, right? So basically there are different kinds of image blurring, right? Gaussian blur, median blur, bilateral blur, all the different kinds of blur, all are having a different applications or different purpose, right? Some, let's suppose if you want to reduce the like noise from your images, okay, so in that case you can use the median blur and bilateral blur, right? It will give you the more accurate output as compared to Gaussian blur, right? But in Gaussian blurring, right, basically this will help to smooth the images, right? But it will hide the noise as well, right? So that's why we can use median blur or bilateral blur when we want a more clear output, right? So let's quickly jump to the software and let's see how we can apply this one. So first we need to import CV2. So first let's read any images, as you know, like if you want to apply to anyone, right? So first you need to read the images. So for that we will use the method imread. And here let's take any images. I'm just taking the images which I have stored in my folder. After this, let's resize the images. We have already did 2 to 3 times. So for that I'll use the method resize. And inside this, first you need to pass down the source, like on which image you want to apply this resize methods. Next argument will be the tuple, that is the size of the images. So here let's suppose I want to keep it 500 comma 500, or let's take it 400 comma 400, right? Now let's apply. So see, actually the thing is that let's suppose if I write cv2 dot imshow, right, and you know here you need to pass down first image, the name of the images, and then the image variable in which you have stored the images, and then cv2 dot wait key, and here I'll pass 0, and then cv2 dot destroy all windows, right? So first let's check this one, either it's working or not. Yeah, everything is fine. Now let's move to, now see, if you can see these images, this is a colored images, right, in the form of BZR. This images has 3 channel, blue, green and red. So let's suppose if you want to apply some methods, if you want to blur these images, right, you have to apply lots of tasks over here, lots of operations over here. So the better one is that instead of this colored images, first let's convert these images into the grayscale images, right? That is a single channel images, so that we can easily apply the methods. Let's see how we can do. So first I'm taking a variable, and then I'll write cv2 dot. So to convert any images from one channel to another channel, or one color to another color, we can use this cvt color method, right? So basically this method, first you need to pass down on which image you need to convert. So I need to convert this image, and then here you need to write on cv2 dot color underscore bgr, because by default this image, this OpenCV will read the image in the form of bgr2, and I need to convert to the gray. So right, so here what I'm doing, I'm converting this from bgr to gray image, right? Let's see if I want to run this images, cv2 dot imshow, and I'm giving the name of this image is gray, and this I'm reading gray. Let's check this one, either it's working or not. If I run, yeah, now you can clearly observe the differences, right? So this is your colored images and this is your grayscale images, or you can say black and white images, right? Hope this clears all of you, right? Okay, now let's move ahead with our main concept, that is image smoothing. So first let's apply the Gaussian blur, right? So here I'm taking GB for Gaussian blur, and for any kind of, let's suppose if I'm writing Gaussian blur. So Gaussian blur is a method whenever you want to apply Gaussian blur. So here first you need to apply on which image you want to apply this one. Second is the kernel size. See, what is this kernel size? Basically it's a matrix, right? Basically what is the concept of Gaussian blur? The concept is that basically you have to apply one geometrical matrix shape, let's suppose rectangle or cube, on each and every pixels of images, right? So that it will blur the images whenever the intensity matches. And let's suppose for here I'm taking 5 cross 5 matrix, and the third argument will be the sigma. It's not mandatory. Here I'm taking 0. Sigma value, it means like how many like the stretch, like where you want to stretch, either in x-axis. Okay, now first let's display the output of this grayscale, right? So here I'm show method, and for this here I'm taking GB for Gaussian blur, and just write on this one. Okay, let's see either it's working or not. Yeah, now you can clearly see the output, right? This one. Okay, so basically this is the you can see this is your original images and this is the blurred images. You can see like this is the brightest, this as has the like bright intensity. In this blurred images you can see basically it has filtered that high intensity like pixels. Okay, now let's try with a different one, right? And one more thing, see here I'm applying this on this grayscale images. If you want to apply on the original images, you can do like this. And now if I run this one, here also you can see this one, right? So this is your blurred images. You can clearly see the differences, right? Now for now I'm just removing this gray one, right? I'm just taking this one. Now let's try with another one, that is median blur. For now here I use median blur. This also, first you need to provide down the on which images you want to apply this one, and then again kernel size. Let's suppose here I'm taking 5, that is 5,5 matrix. Now let's display this one, cv2.imshow, and here I'm median blur, and then the name of variable where I have stored the images. Let's see if I run this one. Yeah, you can see now, you can clearly see the differences. This is your Gaussian blur, this is your median blur, and this is the original image. Okay, by comparison you can see in this median blur, right, you'll get an accurate image, more smoothen as compared to the Gaussian blur, right? So whenever you want to reduce 100% of noise from your images, you can clearly move to the median blur as compared to Gaussian blur, right? Let's try with third example, that is, so first we have done with Gaussian blur, median blur, and there is one more one, that is the bilateral blur, right? So let's see how we can do this one. So bb cv2 dot bilateral filter, right? So here also first you need to pass down the source on which you want to apply, and second thing is the, that is matrix, right? So here I am passing 5, right? And let's display this one, cv2 dot imshow, and the name of the window, for now I'm taking bb comma the variable in which I have stored the output. Now let's run this one, and if you see here, you can see bilateral filter required 3 argument, right? Sigma color also, and let's suppose for now I am passing -1. I'll explain you this one. Okay, and sigma space also you need to pass down. Let's pass it to the 0, and now run this one. Okay, now you can see clearly the differences, right? So here as compared to the all images, right? So basically in bilateral filter you will get a accurate images as compared to the median blur or Gaussian blur. So let's suppose if you want to blur your images, right? If you want to reduce your images, but in the output you want a clear pictures, so clearly you can switch to the bilateral blur, right? So the best option is bilateral blur, second one is the median blur, third one is the Gaussian blur. But if you want to reduce 100% of your noise from your images, you can go to the Gaussian blur, right? So this is the concept of the blurring, image blurring, or we can say image smoothing, right? So I hope all of you understand this concept. Take some more images and perform these all the 3 operations, right? And then try to compare the output. So this is all from this class. I'll see you in the next sessions. Bye everyone. Thank you so much.